Hello, class. Hi. Hi. All right, so we're live on the internet here. So we're taking a look at parallel and perpendicular lines. So here, we're going to go through a little bit of definition first. So two slopes are said to be parallel if their slopes are exactly equal. So if two slopes are exactly the same, they're said to be parallel. So what does it mean when two lines are parallel? So it means that they'll never intersect. So two parallel lines will never intersect unless they are exactly on top of each other, which means they'll infinitely intersect. So two slopes are said to be perpendicular if their slopes are negative reciprocals of one another. So, and perpendicular means they intersect at 90 degrees, or they form a right angle where they intersect. So if we take a look at just the slopes of 2 over 1, negative 1 over 2, and negative 1 over 2, I want to know which are parallel and which are perpendicular. So which pair are parallel to one another? What colors? Yeah, B and C. So the blue and the green. These are parallel because their slopes are exactly the same. So now let's take a look about what we mean by negative reciprocal. Okay, so if I take the negative reciprocal of 2 over 1, what do I get? I get negative 1 over 2. And if I take the negative reciprocal of negative 1 over 2, what do I get? I get positive 2 over 1. So remember, it's the whole sign changes, right? So right now, this whole guy is positive. So if I make it negative, it'll be negative. And then if I take the reciprocal, it's 1 over 2. And if I take the negative of a negative, I get a positive. And if I take its reciprocal, it's 2 over 1. So notice here that this red guy is perpendicular to both the blue and the green. I think things got a little bit shifted when I changed my formatting, so sorry if the graph doesn't exactly match up. I think the dots are where they're supposed to be, but the lines are being a little troublesome.
Oh my God.
I know. I'm sorry, Blake. I apologize. So let's take a look here. So this is just a relationship we have to remember. So the idea is that if you see two slopes that are negative reciprocals of one another, then they're perpendicular. Their equations must be perpendicular to one another. And if they share the exact same slope, that means they're parallel. So by definition, if it's parallel, has the same slope. If it's perpendicular, the slopes are negative reciprocals. Okay? So I want to go through an example here. So you can use this in the white space. And Josh, let's focus up here, sir. So this is in standard form. Okay, this is your slope-intercept form. So I'm going to give you the equation. Y is equal to 3 over 4x plus 5. Okay? So in slope-intercept form, the coefficient of your x value, this always denotes the slope. So it's a really handy tool. Slope-intercept form is really, really useful because it's so easy to pull out what the slope of the line is. So what would the slope of a parallel line be? So if a line is parallel to this one, what would its slope be? 3 over 4. What would a perpendicular slope be? Yeah. So a short cut way to write perpendicular is just upside down capital T because it looks like our right angle guy. So you can say a perpendicular slope is equal to negative 4 over 3. The way to do shorthand for parallel are two slanted lines. So a parallel slope is equal to 3 over 4.
If you were to write it out, like if you couldn't remember the symbol.
No, that's fine. Yeah. You can always use the letters. I just remember that mathematicians we work hard at being lazy and we make very intricate symbols so we don't have to write more than 5 letters at a time. Okay, so any questions with this one, with the idea about perpendicular or parallel? And that's pretty much it. You just have to be able to identify both algebraically. So for instance, what's the negative reciprocal of this? It's this guy. And what's equal to this? It's this guy. Okay? So how do people feel about that? That's pretty good? All right. It's Dees. Yes, sir. Please.
Perpendicular slope if you put the negative on the 3.
Yes, because remember, that's an excellent question. So remember, you get one negative sign. So I could also write this as 4 over negative 3, or I could write this as negative 4 over 3. So remember, with fractions, you get one negative sign, and you get to decide how you spend it. You just can't spend it like, over here. It has to be, you get one of 3 spots to spend it. You got to be a little bit strict. All right, so let's take a look at this next page here. So if you want to turn over. So we're going to be taking a look at forms of linear equations. So there's 3 forms that we take a look at in grade 10. There's slope-intercept form, and this is the one I just showed. So we're going to do a notation update. So we have slope is a super long word. Look how many letters that is. That has like more than 3 letters in it. So generally, when mathematicians see a word with more than 3 letters, we make a symbol for it. So slope, the symbol we're going to use for slope is M. Okay, so now, I know, it's like, how on earth did you get that? There's actually interesting stories. No one is exactly sure why this is true. There's a lot of myths. One of them is that it has to do with the French word monter, which is like to rise or to increase, like you monte the stairs, right? Monte, yes. I can't speak French. I was just playing. So that's actually not true. That's false. But it's a story that made the rounds in like the 1900s. So no one really knows why this trend caught on, but it's like our consistent trend. And we also, y-intercept. Y-intercept, what? That's like 2 words. So we're, of course, going to replace it with a single letter. And we replace it with the letter B. Why? Well, that's a really good question that I can't possibly answer. And in fact, even historians cannot even answer. So when we're talking about slope, we're going to use this kind of italicized M. And when we're talking about y-intercept, we may also use an italicized B. Okay, so it's just some notation. End of notation update. So now we're going to take a look at an example. So the nice thing about the slope-intercept form is that the coefficient on the x is always your slope. And your constant term is always your y-intercept. So let's take a look at these. So what's the slope for this first example? Yeah, negative 4 over 5. What's the y-intercept? 11. Okay, what's the slope for this next guy? And what's the y-intercept? Perfect. So let's say that I have a slope that's negative 4 over 5. What would be the perpendicular slope? Would it be positive or negative? Positive? 5 over 4. What would be the parallel slope? Negative 4 over 5. Okay? So similarly, get a little hand tool here. Similarly, it's blue. So I've got, if m is 8, our slope is 8, what would the perpendicular slope be? Beautiful. And what would the parallel slope be? 8, or 8 over 1, right? I mean, remember, any whole number integer you can make into a fraction by putting it over 1. Okay, so that's slope-intercept form. Slope-intercept form is incredibly useful for finding out what the slope and y-intercept are. It's also super fast for graphing, and from a graph, it's really easy to put it into equation format. Okay? So any questions with this guy, with slope-intercept form? And this is a form that we introduced back in grade 9 as well. So any questions with this guy? Okay, moving on to our next one. So now we've got general form. So I just want to have our little recall here. So recall that the x-intercepts occur when your y value is 0. And, oh, sorry, is it, yeah, sorry about that. Is this guy, yeah, let me know when that happens and I'll move it. And the y-intercept occurs when x is equal to 0. So as an ordered pair, and you remember this is from a similar question we had on last unit, an x-intercept is always your x coordinate, then 0, and your y-intercept is 0, and then your y-intercept. Okay, so that's just a little note there. So the general form of a linear equation, cx plus dy is equal to e, where c, d, and e are just any real numbers. Okay, so c and d are coefficients, and e is just a constant term. So general form is useful for quickly determining both the x and y intercept. So we're going to do this by using a table of values. So we're going to find out the x-intercept occurs when y is 0, and the y-intercept occurs when x is 0. Okay, so we're going to use some let statements here, because it's not in function notation form, so we have to use a let statement. And Kimberly, if you're having trouble seeing, if you want to move to a different desk, sorry, this thing's a little tall. I apologize. So we're going to start with a let statement here. So I'm going to let y equals 0. So that means I'm going to replace every y I see in this function with 0. So this will become 3x minus 8 times 0 is equal to 11. Okay, so now I can simplify this. So anything times 0 is 0, and subtracting 0 causes no change. So I'm going to be left with simply 3x is equal to 11. So now what do I have to do to find out what 1x is? Yes, sir?
5.
Yeah, both sides is by? You got it. And, oh, do I have my pink pen? I left out my, okay. I had a pink pen for my last class, and I made a magenta one too, and all these different colors, but got to find those again. So that's exactly right. So what we get is our x-intercept here is 11 over 3. Beautiful. So what I want you to do now is I want you to use the same technique. For your y-intercept, you're going to get let x equals 0, and I want you to find out what your y-intercept is. Back with us here, so let's draw out. So if I let x equals 0, I'm going to be left with negative 8y is equal to 11. And then I divide both sides by negative 8. So the value that I get for my y-intercept is negative 11 over 8. Right? There we go. And remember, you get to decide where you spend that negative. You can spend it in the numerator, the denominator, or you can spend it in the middle there. So general form is really useful, again, for quickly making up a graph. General form is more difficult, though. If you're given a graph, there's more steps to get from a graph to general form. But graphing from general form is relatively simple, because all we do is we plot the x and y values, and then we draw a line through them. Okay? So I'm going to give you an example here to try out. So I'm going to give you the following general form equation. So we've got 3x plus 4y is equal to 24. Okay? And what we want to do is we want to find out the x and y intercept, and then we're going to want to graph this. Whoa. Whoa. Okay. I'll put it back there because apparently, oh no, I can move it now. Yay. Okay, so we're going to pause. So there's a few techniques that we can do to make things really, really fast. We're going to use a high technology thing that I think everyone in this classroom has. And in fact, this piece of technology allowed the human species to rise to dominance on the planet. This is none other than the human thumb. So you can take your thumb. If you're looking for your x equals 0 value, you can just take your thumb and cover up the x value. Okay? Then you're given the equation 4y is equal to 24. So what do you have to do to both sides to get y by itself? Yeah, so what value do you get for your y-intercept? 6. So using a similar thing, use your thumb to cover up the y guy, and what do you have to divide both sides by? 3. And then what's your x-intercept? 8. So we get 8. So now I'll show you how fast we can plot this out. So I have a y-intercept of 6 and x-intercept of 8. And all I have to do is draw a line between them. Ah! Sorry. This arrow machine, the arrow function, like never wants to go where I put it. And it's like, no, do you want to go up here? How about down there? How about up here? It's like, no, I want you to go right in between. So that's how fast we can graph things using the general form. So it's just x-intercept, y-intercept, plot the points, draw a line through them. So really fast and easy to do. So any questions with general form? All right, we're looking good. So moving on. The last form that we take a look at in grade 10 is the point slope form. So you recall that we get this y sub 1, x sub 1 just refers to, yeah, that's fine, just refers to a given set of points. So here's what we've got. For point slope form is the equation y minus y1 is equal to m bracket x minus x1, where m is the slope and x1, y1 is a point which satisfies the function. Okay? Yeah, still recording. It's all good. Oh, see? Now we're back. So it's, yeah, it's all good. It's just the little thing hides when we're recording. So the point slope form allows us to quickly form the equation of a linear function by only knowing a single point and the slope. Okay? I'm just going to, sorry, the formatting at the school computer versus the formatting for my home computer have very different screen sizes. So now it fits all on one screen. That's much better. Sorry about that. So what we want to do is we want to use this amazingly powerful equation. And this is kind of going to be like one of our main go-tos because it's just super powerful. And we're going to use the information that we have our point, 5, negative 3, and we have a slope 3, 5, and we can really quickly come up with what the equation for this line is. And we can generate further points. So first off, our x1, y1. Well, this is just 5 and negative 3. Okay? Your slope, m, is 3 over 5. So what this says is, what's the value of x1? So what value do we get? 5, yeah. And what's the value of y1? Perfect. So now we're just going to take these values and substitute them into our equation. So what we have is we get y minus y1 is equal to the value of m multiplied by x minus x1. And we're just going to substitute in. So this is going to become y minus, and what's the value of my y1? Negative 3 is equal to slope m, which is 3 over 5, times x minus the value of x1, which is 5. There you go. That's the equation. All right? And this is now the equation of the linear function which passes through 5, negative 3, and has a slope of 3 over 5. And what's even better is that the 3 forms that I just showed you are all on your reference sheet for your final exam as well. So that also means that you'll have these for the test for this unit. So now you'll have to know how to use them, but they give you the general forms and they give you the kind of the basic equations for them. So you'll be able to know how to apply these. So what we want to do though is let's simplify this up a little bit. So let's just clean it up. So let's use green here. So for instance, what I can do is if I'm subtracting a negative, that's the same as adding a positive. So really this is y plus 3. And one other thing I can do as well is I can distribute across the brackets. So I get 3 over 5x. And what's 3/5 times negative 5? What are you going to get? You get negative 3. And notice that right now, after just cleaning up a little bit, it looks a lot like the slope-intercept form. What's the one thing I would have to do to change this into slope-intercept form? Okay, what do I have to do to both sides to get y by itself? Minus 3. So if I take away 3 from both sides, this is how we do a conversion between point-slope form and slope-intercept form. So y would equal 3 over 5x minus 6. Because negative 3 take away, making it more negative, right? So the nice thing is, and this is what we're going to be taking a look at tomorrow, is that we have the ability to go between the 3 different forms. So we're going to take a look at how, through algebraic manipulation, we can go from general to y-intercept, how we can go from point slope to y-intercept to general. So how can we go between the 3 forms? So kind of summing things up here. So slope-intercept form. So I'm just going to change the format a little. There we go. So slope-intercept form is best used for quick graphing or converting from a graph to an equation. General form is best used to quickly determine the x and y intercepts of a linear equation, and it's very useful for graphing equations. Point slope form, you're able to quickly determine the equation of a function when the only information available is a point satisfying the linear function and some way of determining what the slope is. So they each have kind of their own niche, but we're going to be practicing and mastering them all in this unit. And to give you kind of a bit of practice here, we got our last page. And we're going to take a look at pulling some information from a graph. Okay? So from the graph provided, we want to determine the equation of this function. So we want to use both slope-intercept form and point-slope form. So both of these require us to find out the slopes. Remember, we determine slope between integral points. So what's the slope of this function? Okay, I'm going to give you a head start on this. All right, so let's take a look here. So first of all, is this slope positive or negative? Negative slope. Okay, what's the rise? 5. And what's the run? 9, negative 9, right? So we get negative 5 over 9. Okay, so we know that overall it's negative, the rise is 5, run is 9. So these are kind of like quick little methods that we can use. So what's the y-intercept? Yeah, your b value here is 5. So when we're talking about y-intercept, we're saying 5. So what's the equation using slope-intercept form? So it's always equal to y is equal to mx plus b. So what's the value of m?
Negative 5 over 9.
Yeah. And then plus 5. And there's your equation. Okay? So we pull out the necessary information, plug it right in. Now, the nice thing about point slope form is that you just need some point. It doesn't have to be a y-intercept, right? So let's take, pardon me, sorry. Let's take this point right here, okay? So I'm going to use the point 9, 0. And we've got the slope of negative 5 over 9. And we're going to put it into the form of y minus y1 is equal to m onto x minus x1. Okay, so we'll pause here. Okay, so I've got my blanks here. So what's going in this first blank? What's our value of y1? 0. That's nice. So now what's our slope? Yeah, negative 5 over 9. And what is our x1 value? 9. Right, so we're taking away, remember it's positive 9 because it's like you take away the value. So it's like x subtract 9. Very good. That's okay, that's okay. Because remember that your x1 value comes from like this guy, your y1 value comes from this guy. Okay? So what we want to do now is we're going to use algebraic manipulation to show that answer from 1 is the exact same as the answer from 2. Okay? And really, all that we have to do is to use the distributive property here. Okay? So notice that if I just use the distributive property and simplify the left-hand side, what do we get? So y take away 0 is the same as y. And if I use the distributive property, I'm going to get negative 5 over 9x. Now what's negative 5 over 9 times negative 9? Yeah, you get positive 5, because a negative times a negative is a positive. And this is the exact same value that we got up here. Okay? So simply by applying the distributive property, we can show, and sorry, are you asking what the distributive property is? Oh, okay. Oh, okay, so let me go through the details for you, okay? So we'll have y is equal to, so I got negative 5 over 9 times x, and then I'm going to have plus negative 5 over 9 times negative 9, right? And that's using our distributive property, right? So now, think about this. I can make any integer into a fraction by putting it over 1. So our next step is just to simplify. So I'm going to get y is equal to negative 5 over 9x. So now, for fractions, top multiply tops, bottoms multiply bottoms. So I'm going to get plus 45 over 9. And 45 over 9 becomes, yeah, so it's just a fraction simplification. Yeah, so if you're a little rusty with your fraction stuff, just remember that you might want to do things in the long form way. Yeah, please. Yeah. And sorry, I'm fighting a cold right now, so I apologize if my voice is all wonky and off today.
You're a trooper.
I know. No sub.
Just a warrior.
Just woo, making her work. So for our last one here, we want to convert our answer 1 into general form. So remember, general form is where both variables are on the same side. So we had y is equal to negative 5 over 9x plus 5. So now, what do we have to do to both sides of the equation to have the x and y together? Well, we want to get rid of this guy. How do you get rid of negative 5 over 9? What's its opposite? What's the opposite of negative 5 over 9? Yeah, we're going to add 5 over 9x. Okay, so to get rid of the entire term, and this is a good thing to recall, to get rid of an entire term, you have to either add or subtract it. You add it 0 pair, basically. So to both sides of the equation here, I'm going to add 5 over 9x. So let's see what we get. This is going to leave us with y plus 5 over 9x is equal to 5. So you'll notice that in a lot of your questions in general form, the coefficients are all whole numbers. So we're going to use a trick from grade 8 and grade 9 to help us out. How do you get rid of a denominator? If I want to get rid of all my fractions in an equation, how do you do it? There's a special trick. Yeah, we multiply both sides by the common denominator. So what's my common denominator? Or what's the only denominator? 9. So I multiply both sides by 9, and we can think of it as 9 over 1. So if I multiply both sides by 9 or 9 over 1, what we're going to find is I get 9y plus 45 over 9x is equal to 45. And now this can be simplified. And we're going to get 9y plus 5x is equal to 45. So this is the exact same linear function. It's just now in general form. And we're going to get some more practice with this for our homework today, and we're going to be practicing it some more tomorrow in tomorrow's lecture. So are there any questions before we get started on the homework? All right, let's get to it.